Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Khashayar Fereidani. Please excuse me if I said that wrong and help me to correct that. He is the creator of Kanal, which is, I guess I could say, self-proclaimed like the fastest channel library. Is that right?
Yes, I think right now it's on pre-release, but it's not finished product yet, but it is right now the fastest, but we need to polish that further to be sure that it still be faster when we finish the product.
So this is interesting. You use the word we, so it's not just yourself working on this. Is this true?
Yeah, it's true. I'm the main developer, but after that I published it to the community, I got some help from outside of the community, so I can't really say I from this point, and I'm receiving help from Rust community, and we are trying to make the best channel with fastest speed that's possible for Rust and achieve high concurrency performance in Rust, the same concurrency performance that we see in Golang. And my main point is that I'm trying to achieve that kind of performance.
That's interesting because I didn't know like Go's channels could be faster than what Rust has, because I think Rust should be faster because it's kind of more bare metal, no? Because there's like a VM in between Go and the hardware.
Yeah, I agree with that. Golang using a runtime to optimize that context switching. The same thing is with what Tokyo does. That runtime is very efficient in context switching between concurrent applications. So when you are launching multiple coroutine, it's really fast to switch and pass message between those coroutines. It is optimized that way because the main point of Golang is to be a highly concurrent language. We can achieve that kind of performance through optimized channel in Rust too. But currently, until the introduction of Kanal, we didn't have any solution for communicating like Golang does with a clear API between sync and async part of Rust code. So I saw that we need to have something to get access to in both sync and async parts of Rust code and communicate between threads and coroutines that usually Tokyo as a runtime is managing, to be able to efficiently write programs that are native to Rust environment and working without any problems, without any additional barriers that slowing down in writing concurrent code.
Okay, interesting. I mean, where did the idea of this actually come from? Is it just you really needed some performance, or you just have an itch to scratch?
I started exploring the existing solutions, and I really liked the channels in Golang. And I saw that current channels working really good, but they had some shortcomings, like they don't have close signal to broadcast closing of the channel to all the senders and receivers. And another problem that I saw in some of those libraries is they don't have support for channels with zero queue capacity. So zero capacity channels are basically those channels that when you send something, channels blocks until your message is fully transferred to other side. So another problem was that async channels and sync channels were different in API. I needed something to communicate between both sides with a clear API and don't have to switch between multiple libraries in between. So Kanal is here to solve that problem.
I had no idea that Go channels were so quick because I saw in your charts they're really fast, right?
Yeah, they are really fast. Actually, I didn't think that Go channel would be faster than many Rust solutions, but they are fast, but they are not fast because they are communicating between threads. So if you see in the benchmarks that actually they are doing multi-threading and concurrent thread is running, and it's not only context switching in the same thread, Golang performance decreases, even against current solutions that we had in the Rust that last few years. So it's worth noticing that Golang is not switching between threads, it's switching context in the same threads. So the message passing between threads is more costly than context switching because you don't need to wait in another thread for the message to receive. You can just say, okay, this message received to this point. I can context switch to other coroutine and continue from there. If you check that actually our async benchmark is faster than our sync benchmark, because the libraries that are performing on Tokyo is they are using Tokyo as for same as Golang does to context switch, and Tokyo automatically switching between these contexts faster. So when we are switching to sync mode, when we are launching actually multiple threads and communicating between those threads, our speed is going down because of that cost that we are paying for waiting between threads communicate to each other.
Wait, if I understand correctly, you're saying that once Go actually uses true kind of multi-threading, then it really becomes much slower because it's not actually doing multi-threading for the most part. Okay.
Yeah. It's kind of, I have this message. Can I context switch to that context of that coroutine? So it's not like, okay, I'm sending this message to another thread. It's saying, okay, this message is ready for another coroutine. Is it waiting for that? Okay, I'm switching to that coroutine and continuing from there. So it's more of the context switching than messaging between threads. So when switch to Tokyo, we can catch even with libraries like async channel some performance of Golang. We can get same performance on Tokyo. It's not as slow as sync part because sync is doing so much more work in comparison with the runtimes of Tokyo and the runtime of the Golang.
Now, how does this stuff work with sync though? Because when I'm thinking about sync, it can only do one thing at a time, right? So what do you mean by sync and async and kind of mixing the two within the same program?
Yeah, so Kanal is using something called Signal, and a Signal is basically enum for the both types of async signal and sync signal. And for sync API, when a message is transferring to a sync or some thread is waiting for a message, it waits for about, I think right now is the library is about 250 microseconds in sync and is spinning in that loop. And after that, if it does not receive the message, it will park that thread on the signal and wait for the sender to wake it up. So it's like that. It's communicating. First, it's switching to basically working like a mutex that is using both a spinning and thread park API.
Okay, I see. When did work on this actually get started?
I was thinking about another programming language. I had the idea about highly concurrent programming language to develop and release, and I started reading Golang code and I find out about how it works and how it is efficient and how it is not efficient. And I understand that it's not a solution that I can produce like in a short time. So I started searching for another candidate that I can use right now for my projects right now. And I need that to be a stable candidate. So I was watching Rust for about 5 years. I didn't work with Rust in those years, but I was watching the development and progress that Rust is doing. And I really liked the thing that is happening in Tokyo and the stabilization of the async and await in Rust. So I found out that Rust would be a perfect candidate for my current project. I started using Rust and I find that gap. So about 4 months ago, I think, I started developing Kanal. And it was how it started.
Okay, so you said about 4 months ago, is that right?
Yeah, it's 4 months.
Okay. How do you even get started with something like this? Because this is quite specialized stuff you're working on, right? It's just lots of reading of code and benchmarking and papers and then trying, or how do you even start something like this?
I started the actual thought process of is about 1 year, but writing the Kanal is about 4 months ago. But I started reading the codes of the other implementation of those channel in Rust and same in the Golang. I started processing what's the differences, what makes it faster, what's make it slower. So I started developing and I understand that if I'm not starting doing anything, if I'm not starting producing it and coding it, it's not gonna go anywhere. So it's better to start a project, then polish it along the way. As I said before, it's not a finished product and it's need some more work. Seriously need to audit it. The code is stable enough that I will use it in the development of my project, but I don't really recommend it to be used in production yet. I seriously inviting people to use it in their development and see how API works. I like to see the feedback from the community of Rust. And it's like that. I don't know. What should I add?
I mean, I'm just curious about why you. Is it because you know which things are working, which are not, that you're more than willing to use it yourself in your own projects?
No, I like the API really because the thing that I wanted to accomplish with Kanal is done. I really liked it because the API is clean and I can solve those concurrency problems that I have with Kanal. I can't do that with anything else. So it's helping me to develop it and develop my project alongside Kanal before releasing to or zero point 0.1 version. And because it's a good solution for me, I started to using it for my code, but I'm not going to launch that code yet into the production.
Okay, I see what you mean. So, what's actually missing for this to be production ready? Is it just that you just want more people to try it to make sure the API is good?
Yeah,
Or do you actually seriously have some places? So, it's the API problem.
I think API is pretty good. I don't think that API need any change. I'm worried about multiple things and I need community feedback on it. So the things that I am worried right now about Kanal is it's using unsafe. So it needs to be audited better. It needs some time to get audited by community. They should start reading the code, start using it. I'm continuously using tools like Miri to check if there's a undefined behavior somewhere. And currently we don't have any undefined behavior that I am aware of. But we need to investigate the code more to be sure. I'm not gonna release it to the public and then find out that, oh, we have undefined behavior in this part of the code. I don't accept that in the channel. So one issue that I currently have with the kernel is that I think the code need to be tested by more people. And another problem that I have, I'm exploring ideas with spin mutexes. And spin mutexes are not actually, I'm against the spin mutexes myself, but currently in Kanal I implemented a version of a spin mutex that is not current. It's trying to solve those problems that are coming with spin mutexes with some strategies. But I'm not sure about those implementations to be really good for production. It's actually right now proving to be really good in benchmarks, but it could change in production environment. But it's not only the point of the performance of Kanal. If we change Kanal lock to standard mutex, it is still performing and outperforming all the other competitors. And I like to be sure that spin mutex that I'm using right now is really good for the Kanal. And I have idea about optimizing Kanal furthermore that I like to publish in a paper to a journal. And that part is using spin mutex too, but it's not pure spinning, or it's not like that I'm spinning always for the response to come. It's basically optimizing for those edge cases that happens through those communication between threads. It's going to optimize Kanal furthermore, and it's not currently, based on my knowledge, it's not used in any other language or library. So it would be a new idea.
Is there anybody involved or looking at this that's kind of more popular in the community? Like, what's been like the feedback? It's kind of curious about, because that's what you're waiting for, right?
Yeah, feedback is mostly good. I'm getting good feedback from the community. Some people are expressing their worries about the mutex part of the Kanal, that it's problematic in the production. As I said, it's not pure mutex, a spinning mutex. So I'm currently using a strategy that is backing off when it's not able to acquire that lock of the internal of the channel. And that solution is for when we have. So basically, the problem with the spin mutexes is the thread can get preempted in any time, and when you are holding the lock, and other threads gonna keep spinning to achieve that lock. The problem is serious because you are wasting the CPU time when you are spinning. But the thing that right now Kanal is doing is when you are in waiting for the lock to be available, it's backing off when it have no success to acquire the lock. So after a few cycles of trying, it's switching and sleeping for some time, and then it starts to competing to acquire lock again. It's possibly solving the preempt in the threads, but I need to really, in benchmarks, add something, compete with the threads that's working in the benchmark. So I need to use CPU about 90%, 100%, and have some competition with the main threads of benchmark. Some other thread basically should do something else, and I should test that if something else is working alongside Kanal, is it performing well or going to damage the performance and wasting time because of the mutex.
Okay, I see. I do see that you do have a dev dependency for Tokyo.
Yeah.
Is that, I'm guessing you must be coming with some type of async connector already with Tokyo. Is that true?
Yeah, my test on the Kanal is using the Tokyo for testing and for examples of the documentation. I'm using Tokyo to test async part of the Kanal.
Have you tried with any other async frameworks?
Unfortunately not right now, but it's going to work because the API is not using anything besides features. So it's not dependent on the other frameworks.
I was just thinking about this would be something that may be like one of those IoT runtimes. I forgot what's the main IoT runtime for async, but maybe that one may be useful to check because obviously you only have so much, CPU and so quickly that really speed super matters, right?
Yeah, we can check that too. Thinking about benchmarking Kanal between different async runtimes to see which one is performing better. That would be a great benchmark too.
Okay, I see. This is looking pretty interesting, right? What kind of problems do people actually use channels for? Is it really just like when you're doing multiprocessing that you'd be wanting to use something like Kanal?
No. I think for multiprocessing, something like Rayon is really better because if you have a structure or a problem that you're knowing how it should run, you have simply doing the multiprocessing, that would be a better choice, I think. But the thing that actually is channels are solving is people are thinking that Golang is a simple language, but Golang is not a simple language because its syntax is simple. It's simple because it's simple in communication. So channels are gonna simple memory model of the Rust. Golang is simple because it's using channel efficiently. Because channels are a better way to share memory between multiple workloads. So, for example, if you have web application, you can pass through all those layers with channels and distribute workload between many coroutines. And that work without channels is really complicated without pure memory. And if you need to end up using it, for example, like mutex is sending something with mutex for another thread, and also channels helping in distributing work faster. So when you have, for example, a web application that you want to have thousands of the workers to write response to your customers, your users, you can use channels to distribute all of those messages, all of those responses to these call routines. And simply, if you have a response, broadcast it to that channel. As Kanal is multi-producer, multi-consumer, the response can come from multiple sources. All those coroutines gonna efficiently write that response to the clients of your. It simplifies the memory model of the Rust.
I see.
And I think we really need that in Rust because people are complaining about it's hard to learn, and channels can help with that.
You're saying channels can help learn Rust?
Yeah, I think it's going to simplify learning of Rust because you don't have to start wondering about ownerships and lifetimes that much after channels because you are sending the ownership through the channel to other owner. I don't know if I can explain it right, but I believe that is the thing that we can do with channel.
Okay, I never would have thought that channels would be a better way to learn Rust necessarily. It's something I never thought about, to be honest. Okay. Yeah, I mean, I am quite curious about, like what's the next steps for Kanal. It sounds like you said just really making sure the API is solid. Like you said, maybe getting some more eyes on the code base to see, make sure you didn't miss anything, especially security-wise. Is there anything else that's on the horizon?
Another thing is that the idea that I have about optimizing it furthermore. Yeah. And another thing that I like to do is start a GitHub project it's with multiple sample tutorials that it's using channels to solve problems in Rust. So I want to start a sub GitHub project that is containing multiple projects of Rust, and every project is solving some problem that is common in Rust simply with channel to help people learn using channel in Rust.
Okay. Yeah, I never would have thought something like that before, so it's pretty interesting.
Mm-hmm.
Yeah, I mean, I don't think I have any more questions. I mean, I was just really curious about, where the idea came from, how did you get there,
Yeah,
and what's going to happen with it. And it seems like you answered, I think, all those already. Is there anything else that we should know about Kanal before we sign off?
I think so. I only invite people to test it, and I like to see more people using it, so get more response from the community. I think its future is really bright, and it's going to help Rust in many ways, and just that.
Okay, and with that, I really thank you for taking the time out of your day to come onto the podcast and talk about Kanal.
Yeah, thank
I
you.
hope that this will bring in some more eyes and maybe some more ideas and improvements so we can get this out there and finally have something we can gloat about over Golang when it comes to the channels that they have.
Yeah, thank you, Alan, for inviting me. Really appreciate it.
Sure, no problem. Thanks again.